Chapter 7, Worksheet 1, Proportions and Similar Figures. This is going to seem quite similar to dilations, and that's why it comes right after it. So what is a proportion? It's a part, share, or number considered in comparative relation to a whole. Basically, it's that image over pre-image that we did last chapter. How do we determine if two ratios are equal? Well, if they reduce to the same fraction or decimal, they're an equal. Or if they cross multiply and equal the same thing, they're equal. So let's do a little bit of remembering how to solve a proportion from algebra. And this should be basically review. So this is where you cross multiply. Anytime you have two fractions set equal to one another, not multiplied by, but set equal to one another, you cross multiply. So we do 5 times x and we do 6 times 15. From here we solve and we get 18. I know that you guys are capable of solving. On the next one, you have to be careful. When you multiply, you need to make sure you're distributing. This is a monomial 6, one term, times a binomial x minus 6, two terms. So it should look like this when you cross multiply. X times 3 is just 3x, that's no problem. So when you distribute your 6, you get 6x minus 36, and then you solve for 12. Again, you guys can do the solving part. On the next one, in this case, because you're multiplying by 1, you're technically distributing it, but you don't really have to show it because 1 times anything is itself. And we get 7. So that was just a quick reminder of how to solve. In number 1, we have a ratio of boys to girls in the class of 4 to 3. If there are 20 boys in the class, how many girls are there? What you want to remember when you set up a proportion is that you need to have like things compared to like things. So they're telling us boys to girls is 4 over 3. Then I have 20 boys in the class, so 20 is going to go in for boys. I don't know what girls are, so I'm going to switch that to x, okay? And then I have 60 equals 4x. I solve and I get 15, so there are 15 girls in the class. Okay, again, we have a ratio of boys to girls, 1 to 3, but this time they said there are 28 students in the class. That's a little bit different. Students doesn't fit into one of these categories. So what I have to do is I have to pay attention and switch it to girls, because that's what I'm looking for, to students. And notice that my numbers here changed. So boys to girls was 1 to 3, so 3 represented the girls. But students, that would be total, is 4. So anytime they're talking about a total amount, you simply add up your ratio. So 1 plus 3 is 4. That's where this 4 came from. And then now we substitute our values in, cross multiply, and solve. Okay, so using that same concept, a triangle has angles in a ratio of 1 to 2 to 3. What is the size of each angle? So you might be like, oh, I don't know where to start. There's 3 numbers. Triangle angles add up to 180. So I know that I have one angle over 180 always, because 180 is the total. This number 6 came from, again, I need the total. So 1 plus 2 plus 3 is 6, because I'm doing total to total. And then I chose to find the first angle, the smallest angle first, which is represented by 1 in the ratio. So I cross multiply, solve, I get 30. To find the next angle, again, I use the same ratio, and I do my cross multiplication, and I get 60. And notice I used 2 this time because that's the second angle's ratio. And then the last angle, again, if you found these, you could just subtract from 180 now, but I'm just showing all the ratios. C equals 90. So 30, 60, 90 would be the size of each angle. A recipe instructs the cook to use 4 cups of water for 3 cups of powder. If you use 10 cups of water, how much powder should be added? So again, we're talking about water to powder, and that's 4 to 3. From there, if we use 10 cups of water, how much powder should be added? So if we put 10 in for the water, X is our powder, we cross multiply, and we solve. So 7.5 cups. Okay, what is the definition of similarity? It's 2 figures that are the same shape with proportional sides and congruent angles. This should be your mantra for this chapter. Proportional sides, congruent angles. So same angles, different sides. Similarity statement is just like a congruent statement, just now we're using this symbol. This is for similarity, so this would mean similar. Okay. And it's just a statement that lists the proportional sides and congruent angles. So these are in order of corresponding sides again, but rather than the sides being equal, the sides are proportional. The angles, however, so angle A would be congruent to angle D in this case, whereas AB, the segment, would be proportional to segment DE. So this is what that would look like. Angle M is the first letter, A is the first letter, so that goes there. RG to BC, so RG, middle and last, BC, middle and last, GM, last and first, CA, last and first. Okay. MR to MG, first and second, first and last. So I would have to do first and second to first and last over here. So that would be AB. You're just finding the pieces that match. Okay, so there's the rest of those. How do I use similarity to solve for missing sides or angles? So in a circumstance like this, we know that these two triangles are similar because they would have told us so. And we need to find out the missing side. So we just set up a proportion. 28 is to X, as 42 would be to 33, because these have proportional sides. I also could have set up 28 over 42 equals X over 33. There are many different ways to set up this step. If you're not sure if you're right or not, check with someone after you've cross multiplied. So 42x equals whatever 28 times 33 is. That's when you would check. When you solve this, you get x equals 22. All right, this one's a little bit tricky because they've rotated the triangles on us. So you have to pay attention. So we need to figure out what is corresponding to this x. And in this case, it would be the 117. If you pay attention to your angles and the way the letters are ordered, you're going to figure that out. Okay, so I have x over 60, so I went this way. And then I would have to do 117 over 130 because, again, the x and the 117 are the corresponding sides. And you get 54. Yes, you could have done x over 117 equals 60 over 130. Again, there's a bunch of different ways to set this part up, and they're all right. Well, they're not all right, but there's many different right answers. Okay, this one's different because we only have one side. So I know I'm looking for this question mark, but I don't have another number. But they did tell me from A to B is 2 to 3. Now, this is important because this is telling you the direction of the proportion. So 2 to 3, and of course, I just said this is important, and I screwed it up on here. A to B is going this way. So 2 to 3, this should say x over 12. So go ahead and fix that, x over 12. And when you cross multiply, you're not going to get this number. You're going to get a different number, but you should fix that. All right, let's do this again. And I'm pretty sure that was my only mess up, so we'll see. EFGH is similar to JKALM. These letters are there for a reason. What is the value of x? So if I see x here on FE, okay, FE corresponds with JK. So that's 8. So I can set up x over 8. And then I have to find another piece that's going to be helpful. I only have 2 pieces up here. So GH is going to go with LM. Again, I'm using the order of the letters to help me because it's kind of hard to see which way this was rotated. And now I can set up my proportion. So I can set up x over 2x plus 1.5 equals 8 over 18. Cross multiply, make sure you distribute when you cross multiply here, solve, and you get x equals 6. How do I use similarity to solve for missing sides and angles still? We're doing a word problem now. A gymnasium is 96 feet long and 75 feet wide. On a blueprint, the gymnasium is 5.5 inches long. Notice the long and the long. You have to keep corresponding things together. So if I went long to wide, so this is long and my x would be wide. So long to wide, long to wide. I have to go similarly. I could have done 96 over 5.5 equals 75 over x. That would have also worked. And here's what you get as a decimal, which is going to work out to be the 4.3. Okay. And another example. So now I have these little symbols again, which again mean parallel. So remember, that gives you alternate interior angles. That's helpful because it makes you realize that 8 and 12 are the corresponding pieces in this case, not 8 and 11. So you got to be careful with that, okay? So 8 and 12 are your corresponding pieces, and then x over 11 because I started at 8 over 12, so I have to start in that same triangle, x over 11. Cross multiply and solve. That is it. Have a fantastic day, and I'll see you later.